So we will be discussing processing machinery for minor forest crops with equipments and their specifications. So if we define minor forest crops, they mainly include the non-timber items such as bamboo, other grasses, edible or useful roots, seeds, fruits, flowers, plants, or maybe some byproducts of these major produce or some waste material. So a number of people from the tribes or other forest development communities they mainly depend upon the collection and sale of such items for their livelihood. So it provides both subsistence and cash income for the people who live in or near the forests. So these are just some of the minor forest crops, just showing you. So the minor forest produce not only plant products, it can have animal products also. Like animal products, lac, honey, wax, ivory, horns, hides, etc. So major, if we talk about our country, it's mainly the lac and honey or honey-based products. Whether it's a wax or it's you can say the other paraffin wax or some other products of the made from honey, value-added products from honey. Plant products may include grass, bamboos, oils. Oils means the it can be of edible grade oil also, just like our mustard oil or some other oils we use, or it can be essential oils also, or the volatile oils which are extracted from mainly the skin of the or the peel of the produce like citrus fruit or even certain leaves they contain essential oil or volatile oil which are used in perfumes cosmetic industry and they are very high value products although they are extracted from the byproducts or waste material but they are very high value oils essential oils used in very high end industry like cosmetics medicinal pharmaceutical industries. Then we can have the leaves also like tobacco leaves or some other leaves. They are also plant products, tannin, resins like you can say gums, etc. Lac is one such product. So if if we start with some of the produce for their processing, honey comes is like a major domestic as well as a commercial level industry in our country. It is produced wildly in the forest also or it can be commercially produced by using the artificial equipments for the honeybees and there are a lot of equipments have been developed in our university Punjab Agriculture University for processing of honey or for the production of honey and if we are going to start some say some commercial unit we have developed a very good technology for small scale processing of honey. So if we talk about honey, honey is a very high viscosity product as we know. In the winter months, it's a very viscous material. It becomes a very viscous material, very difficult to flow. But it has a characteristic flavor, aroma, color, and texture. So principal characteristic and behavior of honey are due to its sugars and the minor contents such as flavoring material, color, pigments, acids, and materials. They are largely responsible for the differences among the individual honeys, or we can say from where we have collected the honey, which type of flora we have used for the production of honey. So its a flavoring mainly comes from that part. If it's say like if it's grown wildly, then it may have a mixed flavor. But suppose if we are if honeybees are exposed to a certain flora, then they will have a certain flavor. Like if we are producing honey from a sunflower plants, the main is like sunflower, where flora is sunflower, so it will have a distinct flavor. Whereas the honey produced from mustard, it will have a distinct flavor. Similarly, honey produced in the hilly areas, where we are having lot of aromatic plants, medicinal plants, it can have a large, high end value. So it's a good source of carbohydrates, minerals, amino acids, proteins, vitamin, thus considering itself as a complete diet. We can say that honey is a complete diet. So basically the processing of honey is, plays a vital role in maintaining the quality of honey, like which type of honey as well as the machinery used for processing. Actually, uh, honey processing mainly involves its heating. How we heat that so that its flowability can be increased. We can uh, we can put the material into the packaging material easily, and we can handle that material very easily. So as such, processing may not be required for honey. So it's mainly post harvest handling of honey mainly includes, you can say, heating so that the flowability and for ease of filtration and prevent granulation problems and for bottling the honey. So it's mainly related with the packaging. For ease of filtering, because when we heat it, its viscosity is reduced and it can easily flow. Then if it's only the purpose of, you can say, filtration, then we can heat the honey up to 40 degrees Celsius. That is sufficient. And that heat, it will increase the temperature, but will not, if we start heating the honey even beyond 40 degrees Celsius, then increase in temperature will not bring the viscosity further down. So it is almost useless to heat the honey beyond 40 degrees Celsius. If only filtration is the or is the flowability of that honey is our main objective. Otherwise, if we are say reducing the moisture content of the honey, then we can go in for beyond 50 degrees Celsius also, 40 degrees Celsius also. But the care should be taken that we must provide the heat, indirect heat, not direct heat. Like uh, simply we cannot put the you can say fire below the honey chamber or honey container. That will affect its quality. Rather, we have to uniformly heat the honey so that its effect is uniform, and we must use some indirect method. Like if a vessel, we have a vessel, some vessel where honey is put, then around that vessel we can circulate the hot water. So that hot water will provide heat to the honey. Direct heat, like putting the electric heaters directly, it will cause the, you can say, mainly the heat transfer mode in that case is your conduction, which causes the surface deterioration of that vessel, as well as the honey which is touching the surface of that honey, but that vessel will also be affected. So, and the honey should be least processed. Least processed honey is considered as the best. But nowadays, when the commercial activities are involved, the processing of honey has become a necessity even. So honey processing is termed as indirect heating of honey at controlled temperature and durations. So these two things have to be maintained. One is the temperature, another is the duration. How much time we are giving and at what temperature we are heating to facilitate filtration, destroying all the yeast cells. Sometimes what we do, we get uh, we, uh, uh, we collect the immature honey. So lot of yeast cells may be there which have to be killed or inactivated, thereby preventing the fermentation, sorry, and delay granulation, besides retaining its natural flavor, color, aroma, and other constituents. So heating, if we are doing for filtration, it should be below 40 degrees Celsius or up to 40 degrees Celsius, not beyond that. But if we are going to reduce the moisture content or destroying the yield cells, then we can go in for higher temperature also, even up to 50 degrees Celsius. But the duration has to be also, time also be to be noted, so that time temperature combination is good one. Then only we can get good honey moisture content of honey will be better, its quality will be better, and its packaging will be better by processing the honey. Like honey packaging is the main, you can say, the criteria for its processing, because whatever we get in the market, we get the bottled honey in the bottles, maybe bottles, sometimes we get the plastic bottles, sometimes in the glass jars we get honey, mostly in the glass jars we get honey. There are a lot of brands available in the market, but at the farmers level if you go, you may not find some brand, but the quality may be much better. So honey packaging technology is very old in our country, but the new developed technologies, because the packaging of bottling itself is problematic, because honey is too viscous. So we are heating that so that the flowability is increased, and and sometimes numerous air bubbles are formed when we fill that bottle, and that air bubble further, when we close that bottle, it further reduce the quality of that honey. So we must remove those bubbles before, during the bottling. So to so while bottling, the tip of the funnel through which we are filling that bottle should touch the bottle. It should touch some side of the bottle. It should not directly be coming from that funnel and directly going to the bottle bottom. A funnel should touch the bottle so that, and it should remain submerged in the honey to check the air trapping, so that there should not be any air trapping. It's a simple method for air trapping. Or the honey tip should touch the side wall of the bottle. Either it should touch the side wall of the bottle, or yes, it or okay. I start the video also. No problem. So and that will, either it should be touching the wall, or it should be the honey should be submerged. That funnel tip should be submerged in the honey during the filling of bottles. Sometimes these days we are working on vacuum packaging technology also. For most of the food grains, this is very successful vacuum packaging. Like if we pack the pulses or grains or rice or some other crop, the quality of that produce remains intact even after 2 3 years, as far as the grains and the pulses are concerned, because we remove the air completely from that packet, and till that vacuum is maintained within that packet, the quality remains intact. And we are also working on vacuum packaging of liquid material just like honey, and we have seen that like even for a long time the quality of the honey remains same. It's like if we fill the bottles of the honey and then we put it in the vacuum packaging system, so it will suck the entrapped air as well as the overhead air. So that is, you can say, vacuum packaging technology is also coming up these days. It's new technology. Lot of machinery manufacturers are there who are manufacturing this vacuum packaging technology for liquid materials. So when we purchase honey, it must be stressed that the honey does not have froth at the surface, because if it is having some froth or foam type, it enhances it. That means there's some fermentation is taking place, which may reduce the shelf life of that produce. Like this is one simple gadget, uncapping knife. When we are commercially producing the honey, so wax coverings over the honey cells, honey cells, they are formed. So to remove that, we have developed uncapping knife, electrically heated uncapping knife, which electrically as well as battery operated. So it can be AC or DC operated, and very effective machine. many farmers in Punjab state who are commercially processing this, commercially producing the honey, they are using this equipment, and it gives a very good results and very easy operation. Similarly, there is a simple radial honey extractor. This machine is now being commercially available in most of the manufacturers. Initially, it has been developed in PAU at Punjab Agriculture University. It can be either manual or it can be motorized with half horsepower motor made of stainless steel. Because of food grade material we are dealing, so we are using the stainless steel. Its cost is about rupees 50,000. Then we have developed a very honey processing system, small honey processing system. This technology has been recommended by the Punjab Agriculture University, and it does two, three different functions. One function is that it does the heating of honey, indirect heating of honey by using hot water, and where the temperature is controlled. And this machine is quite suitable for the small farmers, and as it can process almost 2 quintals of honey per day. That means we are having a 4 batches of 50 kilogram each. If one batch takes about 2 hours for its processing, so it's having a very good control panel and other accessories. So it's a portable machine. It can be taken from one place to other place very easily, and machinery cost is about 1.5 lakhs rupees, and it requires electric load of 5 kilowatt. This 5 kilowatt is mainly in form in terms of, you can say, the electric heaters which are used for heating the water, not direct honey. So from that heated water we are heating the honey. uh, if we want only filtration, then only filtration can be done. Only we do the heating up to 40 degrees Celsius, not more than that. But if we are, this is a moisture reduction unit also. We can reduce the moisture also, or moisture of honey, because that is the main culprit for deterioration of honey in the, you can say, if the moisture is high. uh, it is this machine is quite useful in reducing that moisture, and its operational cost is very less, just rupees 2 per kilogram of honey. So, like most of the farmers we have contacted here, we have a contact with them. Normally, they sell the raw honey before processing. Raw honey, just like 70 or 80 rupees a kilogram. But when it is bottled, it is processed, it is heated, and it's packaged properly. That same honey comes at a cost of rupees 250 or 300 rupees a kilogram. So you can easily see what are the how much value addition it is taking place, and the farmers who are used to sell raw honey with the simple machines, they can have their value addition very in very good way, and most of the farmers in a group, if one farmer is unable to purchase this machine, 4 or 5 farmers or at the cooperative level, they purchase this machinery and they get their produce processed and packed. So it is this machine is having a mechanical filtration system. It's not like at the domestic level we use some cloth, muslin cloth, etc. for filtering the honey, but this machine is having a mechanical filtration system which further enhances the hygiene as well as the cost effectiveness and the capacity of the machine. And this machine, this technology has been recommended by the Punjab Agriculture University for honey processing system, and one company is manufacturing this machine in Ludhiana, and maybe some other companies maybe there for, in other places also, and this is quite a popular machine. Many such units have been sold in the rural areas of Punjab where the honey production or processing takes place, and it's giving a very good, you can say, the response. It's getting very good response from the processors or small entrepreneurs who are in this business of honey processing or some agro processing business. Then we have another crop, aloe vera. Aloe vera, as you know, this, these days is having a great potential and value in the field of therapeutic, pharmaceutical and cosmetic industry and Ayurvedic Unani system medicine, and it's particularly used for treatment of burns, bleeding wounds, eye drops for sore eyes. The gel contained in the aloe vera leaves reportedly comprises 75 nutrients, 200 active compound, 20 mineral, 18 amino acids, and 12 vitamins. So, so as far as processing of aloe vera leaf is concerned, there are two methods of processing aloe vera leaf which are used or utilized to obtain used ingredient commonly available in commercially available products. One is the leaf processing method where we are simply grinding or macerating the entire aloe vera leaf followed by its purification to remove the phenolic compound found in the latex. This purification step is usually accomplished by activated carbon filtration, which in a process also called decolorization. So we do the like bleaching normally in a natural way using activated carbon filtration, and this activated carbon filtration is a very normal process. Even our in RO system, the reverse osmosis water filtration system, this carbon filtration is used. And when we grind or macerate the entire leaf, aloe vera leaf, then because the solid material is also the part of that maceration, and we have to remove that solid material or phenolic compounds which are found in the latex, and we have to do the filtration or purification by using carbon filtration. So it does two purposes. One is the removing the your this solid part, and secondly to do the bleaching action as well. Sometimes we do inner leaf processing method. Inner leaf processing method, that means aloe vera juice is extracted from the inner uh, rind by removing the outer leaf rind or stripping away the outer leaf rind. So uh, first we strip away the outer leaf rind, then we rinse or wash away the latex and processing the remaining inner leaf material. So sometimes decoloration is also employed in this method. So this is one machine is developed, has been developed for in PAU. This technology has also been recommended by the Punjab Agriculture University. This is aloe vera gel extraction machine where we extract the gel from the aloe vera leaf. So we are actually basically removing the outer end using this machine. This machine is having a good capacity, 1.25 quintals, cost comes out to 40,000 rupees, and it runs with a 1 horsepower motor. That means it will consume just you can say less than a unit of electricity per hour. So quite a useful machine. Although more, this technology has been commercialized and being used, but its use is still limited because in our state Punjab, aloe vera itself is a very you can say minor crop, and uh, with the uh, coming of more entrepreneurs in this crop, the chance of its popularity will further increase. Then another is important crop, amla or amla, which we call Indian gooseberry also. It's also having a good Ayurvedic value, highly nutritive and richest source of vitamin C or ascorbic acid. It's a very rich source of vitamin C. Very high quantity of vitamin C is found in this fruit. Has antioxidant properties as it contains gallic acid. So we can have a number of you can say machines for its processing: amla shredding machine, boiled amla breaking machine, hydraulic juice press, blancher, etc. These are small machines which are used for you can say various unit operations involved in processing of amla. These are the small domestic you can say the appliances, gadgets, which are used at domestic level as well as some commercial level also. This can be used. This amla seed expeller machine, where seed is removed by entering the core of the that fruit, by removing the core of that fruit. These are some of the final products like amla candy, amla segment, amla laddu, murabba, etc. can be formed, and even amla dried products can also be formed by drying the fruit after cutting it into four, five, or six pieces, and then do its drying. And when we do the drying of amla, care should be taken that the temperature should not go beyond 60 degrees Celsius. If we are following the some mechanical drying method, uh, uh, the temperature of hot air temperature should not go beyond 60 degrees Celsius. Uh, and in mechanical drying method, if we are have cut the fruit into three or four pieces, then it may take around, you can say, 24 to 48 hours for its drying, and then we can convert that amla dried material into powdered form also, and we can use at our homes. We are using these materials at our homes also. Then there's another crop which is very unconventional crop, black rice. Black rice is not cultivated throughout India. It's mainly the in northeastern part of the country, like Meghalaya, Mizoram, or some other this northeastern states. This black rice is cultivated, and it sometimes is called some magic rice also, because it's having so many nutritional properties. Uh, Earlier, this rice was given to the, you can say, very high end people, very rich people, kings, etc., kings, or like the posh people of the society. The black rice is mainly black in color due to the presence of anthocyanin pigment on the outer layers or the bran of the rice kernel. Black rice is very rich in tocopherols, vitamin E, iron, antioxidants, and the use of black rice as an ingredient in food processing may help in created value added products. Like if we add some black rice into some other formulations, then it will surely it will increase their nutritional value. In fact, the amount of anthocyanin contained in the black rice is higher than any other grain, including the brown rice, red quinoa, or other colored whole grain variety. Since black rice doesn't go any refining or processing, it is able to retain its antioxidants, vitamins, minerals, and fibers. So the black rice is almost sold as a whole grain with the outermost layer of the bran intact, making black rice technically a type of brown unrefined rice. These days, as we know that even our normal rice, people prefer brown rice, because if we take the normal paddy, basmati paddy or normal paddy, then uh, people prefer brown rice. Brown may not be exact brown rice, maybe some part of the bran is removed to improve its digestibility, but at the same time, we want to have a good nutritional value of that product. So, as compared to white rice, brown rice is much better in terms of nutritional quality. As far as black rice is concerned, it's mainly the brown or unrefined rice. That means we are doing only, during processing, we are doing only one operation, that is dehusking, removing the husk. So the raw uncooked grain look black, while the cooked or soaked grains look purple. The color during cooking, the color of that black rice is changed to purple due to some chemical reactions, or like hydrothermal, due to the hydrothermal treatment given to that, and the result of the mixing of the dark outer layer with the white endosperm within the that grain. So if we see its processing, like normal paddy, when we do it processing, we do mainly the two operations. One is the dehusking, removal of husk. In normal rice, normal paddy, we have around 20% rice husk, and so from normal paddy, we may get nearly 80 out of 100 kilogram of paddy, we may get 70 or 8 or 80 kilogram of brown rice. This you can say as a pure brown rice. But in the markets, the brown rice which we get is not pure. It is slightly polished to improve its digestibility, because the outer brown layer, they are difficult to, you can say, digest, and moreover cooking is difficult also, and it's time consuming process. Brown rice will take almost double time for cooking as compared to the white rice. It may have high nutritional value, but the cooking is difficult and time consuming, and moreover pure brown rice is not, you may not able to find in the market. But whatever the brown rice in the market is sold, some bran is removed, 1% or 2%. In normal white rice we remove nearly 8 or 10% bran, but in the brown rice which we get in the market, 1 or 2% of bran may be removed. So it's basically there are two operations in processing of, you can say, rice: removing of husk and then removing of bran. If we are getting white rice, then we have to remove the bran. Even for getting the brown rice or commercial brown rice, 1 or 2% of bran may be removed. So that and the machines, like I'm showing a dehusker, simple rubber road dehusker we are using. In the modern rice mill system, we use the rubber roll dehuskers for moving the husk content, which is 20% about. And this is, I'm showing you, these are laboratory models where we can, in the laboratory, we can assess the milling quality of basmati paddy, or even some other rice also. But if we want to say install a mini rice mill plant, where in mini rice mill plant, where we are processing almost, you can say, 3 quintals of paddy per hour, and for normal rice we may have paddy dehusker as well as polisher, and then some grader also. So if you want to have all the three machines, like paddy dehusker, then paddy polisher, and then grader, these three machines may cost us around 5 or 6 lakh rupees, in which we can process around 3 quintals of paddy per hour. So out of 3 quintals of paddy, if the recovery is 65%, then naturally we will get about 2 quintals of rice out of that. But in case of black rice or this, where only dehusking is required, then we may have only one machine, that is dehusker, paddy dehusker. And uh, this machine, may start, cost may start from rupees 1 lakh also, depending on the capacity. And because Punjab is not producing any black rice, it's mainly the basmati paddy or normal permal paddy. And but some farmers, they are having a small milling units, mini rice mill units, which they mainly process basmati rice. And this machine is a part of the agro processing complex, which the concept we have developed in the PAU, where we are having 3-4 different machines. One is like this, you can say, mini rice mill, mini rice mill, and other is like this flour mill unit, and third one is the oil expeller unit, fourth one is the spice grinding units. The 4 machines, they are, when they are installed at the same place, then we call it as a agro processing complex. And every year at Punjab Agriculture University, with the help of Punjab Agriculture University, we the farmers, they nearly set about 10 such plants are being set with the technical guidance of our department of Punjab Agriculture University Ludhiana. And they are running very successfully because whatever the products we process there, they are of daily use. Like wheat flour is of daily use, oil, mustard oil is of daily use, spices daily use, and then rice also, permal rice may be of daily use, and they don't face any problem regarding their marketing of their produce, and it's quite successful business. But uh, if we don't want to set up agro processing unit, we can have a separate unit also, like suppose only for basmati we want to set up, or for black rice processing we can have only a dehusker that may cost us rupees 1 lakh only, and that will be helpful in getting the edible product from that paddy. So that is the another aspect is the another major crop, like it's not exactly the crop, rather it's the we getting some valuable product from waste, that is the essential oil. In almost you can say,
Sir, can you unmute yourself? Sir, you're not audible, sir.
okay, there was some very important phone call that I had to. So what are the byproducts? All these natural byproducts, most of them they contain volatile oil. It can be from the plant, scrub, tree species from the various parts of the plants. Not me. It can be from the roots, rhizomes, like turmeric is a rhizome, and we get essential oil from turmeric, woodwork, leaves, eucalyptus leaves. We can have this essential oil. Then flowers like rose flower or some other flowers, we can have this uh, um, essential or volatile oil. Seeds, like seeds, you can say like this cloves or this spice plants, cloves, cardamom, etc. All they contain essential oil or volatile oil. Even of some of the like citrus fruit peel, the outer peel, it contains a good quantity of essential oil. They are mainly, although the products we use for getting the essential oil, they may not be of much value. Sometimes they are considered as waste also, like citrus peel is considered as waste. But whatever the product we get, like the volatile or essential oil or some other valuable component, that's a very high end product. Essential oil, volatile oil, as I told you earlier, it essential oils, they uh, they are used in number of industries, like in cosmetic industry, flavoring industry, pharmaceutical medicine industries. They are being perfume industries. They are extensively used. And but how we extract that oil, that is also important. We are using either hydro steam distillation or expression. Main method is either hydro or steam distillation. Uh, like when we extract like mentha oil, we extract it by using the steam distillation or extraction. So this is like essential oils. They are getting from barks, cinnamon, then woods, roots, etc., gums, seeds like fennel, coriander, nutmeg, etc., fruits, orange, lemon, juniper. They contain rhizomes like ginger, calamus, curcuma, or this turmeric. Flowers, almost all flowers they contain, because of their flavor, they contain the essential oil, rose, jasmine, orange, clove, etc. Similarly, leaves. leaves like mentha leaves, they are used for extraction. Lemongrass is there, from where we get the then stems also. So all these are the sources of essential oil. Some of these sources may be valuable products, some of these sources may be the waste products or byproducts of the system. But as far as extraction of the essential or volatile oil is concerned, almost the same method is employed for their extraction. It's either the steam distillation or the hydro distillation method. So, like if you put plant material and water into it, into charging distillation still, we get the distillations from which we get the essential oil. Essential oil carried by the mixture, whatever the essential oil there, it's carried by the mixture. Then with the help of condenser, we separate the water and oil mixture, and oil separator, we get the essential oil and distillate. So basically what we do, essential oils are mostly lighter in weight, and they are volatile. Volatile in the sense, we say this their boiling point is very low, about it's about 60 degrees Celsius, and if you keep a bottle of essential oil open in the on outside, the essential oil will evaporate. That's why they are also called as a volatile. Essential essential word has come because the essential oil means this oil essential to the plant to which they make a part, because they are basically the insect repellents also. So they protect the plants naturally, like if we say the citrus fruit or kinnu fruit, the its outer skin, it contains the oil, and it acts as a insect repellent. So it is essential to the plant. That's why sometimes these oils are also called the essential oils. So, and we use water or steam in gaseous form for its extraction, because we know that water is having a, the water and essential oils, they are uh, they can be mixed, but they are not soluble in each other. When they are collected, they will form the different layers. Water will form the bottom layer, and oil will form the upper layer. Because oil is lighter than water, it will form the upper layer, and due to their boiling point difference, water boils at 100 degrees Celsius and the oil boils at 60 degrees Celsius, and when in the distillation still, both are converted into vapors. Water will be converted into vapors and oil will also be converted into vapors, and during condensation both will be condensed, water as well as essential oil, but they will form the different layers. Oil upper layer, water bottom layer will be of water, and that bottom layer is separated, oil separator, and we get the essential oil and distillate. This distillation is also very important. Like uh, when suppose for example we are extracting the oil from rose, so whatever the water we have used for its extraction from rose, one component will be the rose essential oil, and whatever the distillate is there, it's known as rose water, which is again used for makeup in the makeup industry or cosmetic industry. So that also becomes, because that rose water will have a certain uh, flavor or certain odor or smell. So we can use the simple water in a liquid form, we can use the dry steam also, but the process is almost same. In both ways we are using water, one in the liquid form, another is in the gaseous form. It only, you can say, the sometimes the efficiency of the steam distillation is better as compared to that of hydro distillation. And in laboratories also we can extract this oil by using the hydro distillation. This is a very simple Clevenger type hydro distillation apparatus which is being used in the laboratory. And here in the bottom flask we put the water as well as the oil bearing material. It may be you can say citrus peel, it may be turmeric, it may be rose, dried rose, and when this heated up, both the water as well as the this essential oil, they are evaporated, they are converted into vapors, and when they move up, they pass through the condenser, and in the liquid form they drop in the graduating funnel or this tube, and the bottom layer formed is of water and upper layer formed is of oil. The bottom layer is continuously removed by opening the gate valve, and we collect the essential oil in this way. So Clevenger type this laboratory scale hydrodistillation apparatus can be used for this purpose, or sometimes we have developed in our university, we have developed a system where we are uh, producing the steam for distillation purpose using the solar energy. So we are using the solar energy by using the some collectors, solar collectors. We are converting the water into steam with the help of the solar energy, or we can have a hybrid system if our solar system is not that strong. So up to some extent, water is heated with the solar energy, and thereafter it is heated with the electric energy. So it is a hybrid system. So in a hybrid system, we are using both, and the steam so produced is used for distillation purpose. This is again a system which photo you are seeing. This is again a system uh, which is similar to the Clevenger apparatus used in the laboratory, but at a you can say the you can say it has been a it can be used for a larger quantity of material. In laboratory, we can use only 100 or 200 gram of material just to see the amount of essential oil present in that. But in this one, we can use it as a small at a small scale level for extraction of essential oils. So this material, this machine has been developed by the Institution of Himalayan Biosource Technology, Palampur, and use of borosilicate glass and batch capacity. We can load at one time 4 to 5 kg of material or 8 to 10 kg. There are two models available, 4 to 5 kg and 8 to 10 kg of material is loaded into the vessel, and here we use water distillation, water steam distillation or steam distillation. And method of heating is we can use LPG burner or fuel wood or some other agro based or electric energy. And the cost of apparatus is nearly around rupees 17 18,000 rupees for 25 liter and 28,000. This cost may have further inflated because these data are slightly old. And the fuel wood for 4 to 5 kg, it will require 15 kg of fuel wood for one batch, and one person will be required for 4 to 5 hours for this extraction, and water and other utilities are separately required. So these are the specifications of this machine along with their cost. Exact cost may be obtained from the institution from where this machine has been developed, or some manufacturer may be there who has who is manufacturing these units at the commercial level. Then another important parameter in most of the products, whether they are minor forest products or the normal products, drying is the major operation, energy intensive operation. And in almost all the, you can say, these food processing operations at domestic level, drying is carried out. Drying is the major unit operation, you can say. And in our university at PAU, we have developed this solar dryer. This solar dryer is recirculatory type solar dryer, where the hot air is recirculated to use it again and again. You can see here, there the solar collectors are of evacuated tubes. These are very efficient method of uh, heating the air. and the air heated from these solar collectors is put into the this poly house, or you can say the greenhouse type structure. So we are not exposing the produce direct to sunlight. We are heating the air with the help of sunlight or the solar energy, and that hot air is used for drying the produce. And for drying the produce, this is the inner view of the greenhouse or polyhouse, where the trays are kept. And on the trays, here you can see turmeric is being dried. This dryer was firstly basically developed for the purpose of drying of turmeric, because nowadays in Punjab also lot of farmers uh, they are involved in the cultivation of turmeric because of good returns, and and uh, and most of the farmers who are cultivating the turmeric, they are also processing it. So that so when they are processing it, either they have to dry the produce in the sun, or they can use this type of solar dryers. Many farmers, they have installed this type of solar dryers at their at their entrepreneur where they are in the industries, and or they're at the field farm levels. Uh, they have installed these type of solar dryers, and these dryers, as you can see, they are quite effective in drying of the produce, because as compared to sun drying, it takes almost half the time. Like in for this turmeric drying, it takes nearly 15 days for its drying, especially during the months of March, April, May, and June. It takes nearly 15 days if we dry the produce in the open sun. But the same produce can be dried in this dryer in almost half the time. And these dryers are having a good capacity. That means at uh, in a one batch, we can load up about 5 to 10 quintals of turmeric in one batch. So it's not simply a simple domestic solar dryer, it's a commercial dryer which uses the solar energy, and it's having a good capacity also. These type of dryers are quite successful, and at many places these dryers have been installed, even in the states like Uttarakhand, in Ladakh also side, in Punjab, many such dryers have been, even one or two such dryers have been uh, installed in African country, Tanzania, and these dryers have been entirely designed and developed at Punjab Agriculture University, and this technology has been approved by the Punjab Agriculture University for its commercialization, and some farms, they are having a MOU with the PAU to install or fabricate these type of dryers, and these type of dryers, they are even used for drying of figs, fig drying, then red chili drying, even this fenugreek leaves or methi drying. They are quite successful, because in this dryer we can easily get the temperature up to 60 degrees Celsius, even during the months of December. If there is a sunlight, there is a sunshine, we can get temperature inside the this greenhouse up to 60 degrees Celsius. And there is a provision in this dryer that if the humidity of the air, hot air, goes above 65 or 70%, there is a provision of exhaust, so that that humid air can be removed from the inside of the dryer, and new fresh hot air is introduced into this dryer. And if you see that these are available in the capacity of 3 to 7 quintals per batch. Power required is 1 horsepower, and temperature attained up to 60 degrees Celsius temperature can be attained. And but it's power required is mainly, it is electric power is used for the flow of air, flow of hot air. We use the blower, etc., for which we have to use some energy to make the air flow, or we may have a 1 kilowatt or 1 horsepower photovoltaic cell, so that no electric power is required for that, and time of drying is half that of sun drying time. And these dryers are quite successful, and many places in Punjab, as you know, uh, they are being installed, they are being used very effectively. And uh, just a minute. Uh, just a minute, I start in 1 or 2 minutes. Okay, so we are discussing about the this recirculatory type solar dryer for uh, for drying of most of the crops. Then uh, we also made one dryer which works continuously, solar dryer, which works continuously. It's a solar hybrid dryer. That means uh, during the sunshine hours, we are using the solar heat, solar energy, and after the sunshine hours, we are using the electric energy. So there's a two systems of energy. One is the solar energy, another one is the electric energy, or some other form of the energy. But the limitation of this dryer is that these are of very small capacity. About 50 kilogram of material can be loaded, but this 50 kilogram of material can be dried within 48 to 40, almost 48 hours, depending on the type of crop. Like for turmeric, it may take 48 hours, 48 to 60 hours. For other crops, like if we are drying some forest crop, like we are drying some leaves, say fenugreek leaves or kadi patta leaves, then it may take just 4 or 5 hours to dry that produce. And uh, this is having a almost you can say, when in the summer months, when this dryer is operated during your sunshine hours, it will consume a very small electric energy in the form of the blower, which is pushing the hot air into the drying chamber. So that uh, blower is using only one unit for 4 hours. Like it's having a 0.25 kilowatt capacity. That means it will be using only one unit for 4 hours. But when it is run on the electric system, like after sunshine or at the night time, then in the summer months, it may consume one extra unit per hour in the form of electrical energy. But if this dryer is run during the winter months like December and January, then it may consume 2 units of electricity per hour, depending upon the type of temperature of drying we are temperature of the hot air. So I'm talking about when we are using hot air temperature of 60 degrees Celsius, then in summer months it will consume one electricity unit during off sunshine hours, and in winter months it will consume almost 2 units of electricity during the off sunshine hours or during the night time. So this dryer is quite if we are to dry a small quantity of the produce, then it's quite useful. And there are certain products which are to be dried continuously till end. So for that case also this is very important, especially the your leafy crops. This is quite useful. Even for red chili also, where we don't want that direct sunshine should not be there on the chili, because that deteriorates its red color and its market value. This dryer is quite successful, and even for the high-end products like if you are to dry ginger or garlic, etc., this can be used, or some like other medicinal plants. This machine is quite useful, uh, and this technology has still not been commercialized or approved by the industry, but in the coming years, 1 or 2 years, this may be commercialized or and recommended after its thorough testing at the farmers field. And this dryer may cost around rupees 80,000. When it comes in the market, this dryer may cost around rupees 80,000, and this is quite useful. Then, if we are to extract some edible oil, already we have discussed about the essential oils. Another one is the our edible oil. Edible oils like mustard oil. What is the difference between edible oils and essential oil? Essential oils basically these are not oils. These are basically aldehydes or ketones which give flavor. And whereas edible oils actually they are the triglycerides having a boiling temperature of more than 200 degrees Celsius. So if we try to extract it with the water, it's not simply possible. We have to, if we are using some chemical method or solvent extraction method, then we have to use petroleum ether or hexane for their extraction. But that is not feasible at the farmer's field, because the petroleum ether or hexane which are used in solvent extraction techniques, they are highly inflammable and cannot be controlled at the farmer's field. There are a lot of complexities involved, and there are a lot of processes are involved again to separate the edible oil from that solvent. Ultimately we have to separate the solvent from that oil to be which is to be used. And in solvent extraction technique, a lot of, you can say, the other materials are also extracted, but the best solution is using the mechanical expeller. For most of the oil seeds we can use mechanical expellers. The edible oils can be obtained from the oil seeds like mustard, sunflower, groundnut, etc., but can also be obtained from the oil bearing materials. Oil bearing material means which are not the oil seeds, like rice bran. Rice bran is an oil bearing material. The rice bran, it contains nearly 15% oil. But again, the problem is that we cannot use expeller for rice bran oil. Rice bran oil has to be extracted by using the solvent extraction technique only, and it has to be employed at a very high level. At farmers level, this is not a feasible technology, but for most of the oil seeds, whatever the oil seeds is, it may be groundnut, it may be sunflower, it may be mustard, they can be extracted using the oil expeller, where we press that oil seeds with some pressure. Temperature is also increased during that extraction and or expression, and the oil is extracted. These days, very good expellers are available in the market, and uh, which extract almost all the oil, and only 5% oil remains within the oil seed meal, de-oiled meal. And uh, uh, this essential, this oil, edible grade oil, this extracted, and then it has to be filtered. So it comes with the two machines. One is the expeller, another is the filter press machine. So we are using these two machines, uh, this oil extraction, oil expression, and then filtration. So as far as mustard oil is concerned, mostly the farmer use this expeller for extraction of mustard oil, because mustard oil as such we are using at our homes without its refining. Whereas other oils may require to be refined, like sunflower oil, etc. So they are to be only, we can get the crude oil by using the expeller, but as far as mustard oil is concerned, we can simply extract that oil, filter that oil, and use it for our edible purpose. So when we extract the oil from the oil expeller, uh, we have to put the oil seed meal again and again about 3-4 times to get the maximum quantity of the oil, so that oil in the oil seed meal remains below 5%. And then that oil, it contains lot of it may contain some materials, unwanted material, which has to be removed. And so we keep that oil for 24 to 48 hours in the settling chambers, where due to sedimentation heavy impurities, they are separated out. And then whatever the lighter impurities are there, then after 48 hours we pass that oil through the filter press, where with the help of pressure we do the filtration and remove the lighter impurities. So there are two terms. One is the you can say filtration, another is refining. Both remove the impurities, filter as well as refining. But the nature of impurity is entirely different. In filtration, we remove the insoluble impurities, and that is feasible at the farmer's level or at a small scale level. But in case of refining, refining means removal of the soluble impurities, the impurities which are soluble in the oil. So those impurities have to be removed by using either some chemical technique, or maybe some one or two physical techniques also. So if we are going to use the refine the oil, that means we are separating out the soluble impurities, the impurities which are soluble in the oil. So what type of impurities can be soluble in the this, like color or color pigments. Color is a soluble impurity in the oil, and we have to remove that. So in the refining process, we have the, you can say, bleaching action or decolorization. This is one step unit operation. Another one is removal of the free fatty acids. There are free fatty acids which are soluble in the oil, but which can deteriorate the quality of the oil, have to be removed. So during refining, we remove the these free fatty acids by using the alkali refining or some physical method of refining. Again, this is not possible at the farmer's field. Then third soluble impurity is its odor or its smell, or you can say there are certain odor containing substances in the oil which are soluble in the oil, and they have to be removed by using the steam, water steam, hot steam, etc., so that the smell of that oil is removed. Then some gummy material, phospholipids, etc., may be there which have to be removed. So basically the refining process consists of your bleaching or decolorization, then removal of free fatty acids or alkali refining, or removal of odor or deodorization operation, then degumming operation, etc. So or sometimes waxing operation is also there. There are some waxing material which solidifies at the lower temperature, has to be removed. So all these operations, they need a chemical process and cannot be stored at the farmer's level. But the filtration part, where we are removing the insoluble impurity, this can easily be done at the farmer's level, and we use the filter press, or we can have a double filtered oil. Sometimes there are two filter lines of oil passing from one filter to another filter to get a very clear oil. So it depends upon all that. And the cost of these two machines, this expeller and filter press, it may be around 3.5 lakhs or 4 lakh rupees. But we need a electric load of 10 to 15 kilowatt, and this machine can process about 60 kilogram of oil seeds. Space required is about 50 square yard. So there are many manufacturers in Ludhiana, in Punjab, which are manufacturing this your madam, which are, you can say, which are manufacturing good quality of this oil expeller systems. Then we have developed some turmeric processing machines also. This is one machine which is used for washing of turmeric. This is having capacity of one. The same machine can be used for polishing of turmeric also. So these two machines, with just one machine we can use the two unit operations of turmeric processing. One is the washing, another is the polishing. Washing means removal of the upper impurities, soil, etc. from the crude turmeric or raw turmeric, and polishing is removal of the outer layer of the dried turmeric. For drying of turmeric, I have already shown you the solar dryers. So we have developed almost all the machines for turmeric processing. One is the washing machine we have developed. Then it's a drying system. Solar dryers we have developed. Then we have developed the polishing machine also, the same machine which we used. We do the grinding. Grinding is small hammer mill grinders are available in the market, which may start from rupees 20,000 or so, depending upon the capacity of that machine. So this type you can say turmeric, as far as turmeric is concerned, because a lot of farmers in Punjab, they have started cultivating turmeric as their produce, and uh, 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 and for that we have to develop certain machinery so that the small farmers can process his produce. Suppose a farmer is having about half acre of turmeric cultivation, so nearly 50 quintals of raw turmeric will be produced. And we have the here in our university the pilot plant facilities for the farmers also. There the farmers can bring their produce for its processing, like boiling operation, polishing operation, drying operation, and packaging also, as well as grinding operation. And on a certain nominal rates, and whatever the machinery we have developed, even the small farmers, they can also install at their own field. And turmeric processing is such a type of business, you can say, where we can do most of the operations manually also without the help of machines. But at the same time, we can also install the machines to enhance the capacity of the plant, or you can say the other things for their packaging, processing, uh, and these days trying for turmeric processing, we have discussed some of the machines. Then we have developed dryers for drying of leaves, especially curry leaves. They are you can say uh, dried in a very short period of time without changing the color of the curry leaves. Then leaves like this Kendu leaves, these are also not very popular in Punjab, but in Odisha or Bangladesh, West Bengal, they are called Kendu or Tendu leaves, which is wrapped around tobacco to make the BD, etc. And here also we have to use the drying operation. I'm not very conversant with these type of processes, but just for the here also in drying is the major operation done in the in the fields, so that the proper industry is formed for this purpose. Then another crop is the tamarind, or what we call it imli, and this is also very delicious sweet or sour fruit that has a wide variety of use both for medicinal and culinary purposes, like that. And various equipments used in turmeric processing is depowder, pulp and seed separating, tamarind pulp mixer, juice extractor, juice filter, evaporate concentrate dryer. So I told you that dryer is there in almost all the operations, all the crops, whether minor crops or major crops. This major, you can say, the equipment which consumes most of the energy, and also is essential in almost processing of every type of this plants. So turmeric powder is prepared by mixing the pulp and diluent in the mixer and grind in the grinder. These are some of the photographs of turmeric dehuller, seed removal machine, slab cutting machine, tamarind cake pressing machine, shred packaging machine also. There we do the so it's as far as methods are concerned. This is I have taken from some other source material. Storage tamarind with salt, deseeding, tamarind bricks, tamarind pulp, tamarind candy, etc. So this is a process I have written for tamarind bricks. Similarly, for making a turmeric candy, there are number of unit operations which is written here. Then cashew processing is not a part that. Then another very minor forest crop is the lag or the resin or the gum which is obtained from the insect lag. And three countries, India, Indonesia, and Thailand, the major producer in our country, Chhattisgarh, Jharkhand, MP, West Bengal, are the main uh, the states which are producing this lag. And this from the stick, just like we have seen these sticks, from the sticks, while we do the crushing and then sieving and washing it manually and drying under the sun or shade, and then winnowing so that the other materials is removed, grading is done, we get the seed lag. So these are number of unit operations. Here also you can see the operation drying is there. So basically two operation, grinding and drying. Then we get the graded material, lag. So it's a small scale lag processing unit which has been developed by Indian Institute of Natural Resins and Gums, Ranchi. Now its new name is National Institute of Secondary Agriculture. Its earlier name was IIANRG or Indian Institute of Natural Resins and Gums. So the cost of the unit-wise operation, the crusher is there, then it's other type of machine there. So total cost machine is around 2 lakh rupees and 100 kilogram per day. We can process this complete line is there for lag processing. Similarly, there are other machines like for making leaves, etc. So these are some general operations like what type of products can we can make dry from dried leaves. We can make some composite disposable plates, etc. Industry there. So these are the main, you can say the, I have discussed with you the machines which are used in processing of minor forest crops or some traditional crops. I have discussed with you the turmeric processing, the machines developed in PAU for its processing for various unit operations including washing, drying and polishing, grinding, etc. and packaging also. Similarly, I have discussed with you the this honey processing machines which we have developed here in PAU and the which are quite useful for the small farmers or who are in the honey processing business or in honey production business. Then we have discussed with you the uh, how to extract the essential oil from the waste material or the some low quality products or the byproducts. We can extract the very high value high end products by using a simple cleavanger type apparatus or a distillation unit. uh, then we have discussed with you that how the mechanical expression uh, expellers can be used for extraction of edible grade oils like mustard oil or some other oil. Similarly, oil, we have discussed with you the processing of amla or ola and this aloe vera processing machine we have discussed. Then yes, processing of black rice, whether we want dehusking operation or we want a polishing operation, depending upon that type of operation, we can have a dehusker machine. Simple one machine may cost us rupees 1 lakh, but if we want to have a polisher, then the cost may be increased, and we can get fully brown rice or a partially refined, partially brown rice or a fully white rice also, depending upon the needs of the market. and consumer preferences, we can have different type of final processed product from rice. For black rice, we don't need a polishing operation. It's only a de-husking operation that is done. And so all these machines, I think you have might have found this my presentation quite useful, or it may require some further, you can say, modifications. I want to have your views about this presentation. I am going to stop this my presentation, and if you want, you can have your this comments or feedback or your queries. This is open for discussion. We can have a 15 20 minutes discussion also. I have kept this 15 20 minutes for discussion. So if you want, you can uh, continue with this.
Thank you so much, sir.
Thank you
Uh,
very much.
Participants, if you have any question, you can write in the chat box and you can unmute yourself. You can talk with sir and discuss your queries. Sir, participants are asking for the presentation.
Okay, ma'am. I'll send you the presentation by mail.
Yes, sir.
You can
Definitely, sir.
then you can share with the participants then thereafter.
Yes, sir. Yes, sir.
Okay,
Yes,
I
sir.
don't have any
Very well.
problem.
No, no, no,
I'll
no.
I'll share the this, but it
Yes,
may
sir.
not be like in certain aspects in the party. This presentation may not be complete, but it will be quite useful for the participants for preparing their for as a,
Exams, sir.
you can say, raw material for their further improvement.
Yes, sir. Yes, sir.
Yeah,
Definitely.
that's it.
Yes, sir. Participants, if you have any question, you can write in the chat box or you can unmute yourself and talk with sir. Sir is here to clarify your doubts. Apart from this PPT, if you want any question, you can ask sir.
Actually, I have kept some time for discussion. Otherwise,
Yes, sir.
actually,
Yes,
this
sir.
presentation could have gone up to 4 p.m. also, but I thought we let it be for 15 or 20 minutes for discussion.
Yes, sir. Yes, sir. Yes, sir. Participants, you can talk with sir also. You can. Yeah, sir. Hitesh,
Yeah,
sir,
Hadish
you
Pandey,
can.
you want to
Yes, sir.
ask something?
You can
Mr.
unmute
Hadish Pandey?
yourself.
Yes, sir.
Yeah,
Good afternoon, sir. This is
good
Hridesh
afternoon.
from Anand Agriculture University.
Okay.
Am I audible?
Yes, you are audible.
Uh, Sir, I was interested in knowing more about this aloe vera, this machine, and this processing of this aloe vera.
Uh,
Can you highlight a little bit?
Yeah, actually, this aloe vera machine, which we have developed about two year back in our Department of Processing and Food Engineering at Punjab Agriculture University, Ludhiana, and this machine has been recommended for gel extraction, or the, you can say, the main purpose of this machine is to remove the outer rind of the aloe vera leaf, so that we can extract the gel. And this machine costs about rupees, I think around 50,000 rupees or so, and about 1 horsepower power is required. This technology has, this machine has been recommended by the university, and one manufacturer is manufacturing this machine commercially also. At present, I don't have the that address of that manufacturer, but I'll share it with the organizers of this training course, and you can certainly take help from them. This information I will surely send.
Yes, sir.
Yeah.
Thank you, sir. Uh, any questions, participants? Sir is here to answer your questions. Apart from this PPT, or with the in any doubt you have.
You can write in the chat box also. No problem.
Yes, sir. Because you have to give the assessment, so better you clarify your doubts. That's all.
Sir, there is one more doubt. Uh,
Okay.
yeah, more doubt in the sense, what are the crops which are to be included in this minor forest produce category? in the morning we listen more about the spices thing, whether and then
No, actually, sir, this depends upon state to state. Like if we talk about Punjab, just I'm talking about Punjab state. Then the this minor forest crop is the kadi patta leaf is the major crop, because in Punjab the forest area is you can say northern Punjab is having some forest area, and there kadi patta leaves they are we don't need to cultivate them, they are already there. And some group of women they start collecting this kadi patta leaves, and they came to us that we want to forest some company wants to have a dried product, dried kadi patta leaves as and then we provided them one dryer, simple dryer, which I have shown you that this is a hybrid dryer for drying of curry patta leaves. It takes about 3 or 4 hours, and their product after drying was well accepted by that company. And they are like dried curry patta leaves. They are getting about rupees 100 rupees a kilogram. They are selling that ladies group is selling that crop. So it depends upon state to state that which type of geography you have and what type of the wild crops which are being grown there. And sometimes you don't need to have a like the crop. We may have some crops which are cultivated, like in Punjab itself you can say turmeric. Turmeric is basically a South Indian crop, mainly grown in Andhra Pradesh, Tamil Nadu, Maharashtra, these type of states. But this spice crop is also coming under the, you can say, a, although it's a spice, this spice crop or the medicinal crop also we can put it in. Uh, but this can also be come under the, you can say, the sometimes forest crops, because like here this crop is grown in a small patches, like maybe one-fourth of an acre or even smaller than that. And like they are processing that produce. Similarly, for northeastern crops, black rice is a forest crop, while minor forest crop can be called it as, or some it may not be crop, simply you, some tribal women or tribal person they are collecting the waste material like leaves, etc. So that can that crop is that becomes a minor forest crop. Some like lag raisin crop, which is a, you can say, the animal based, or this is not a plant based lag is coming from the insect. So that is again you can say the forest crop. So it depends upon the state to state. Uh, I may not have that much knowledge about the some other states like northern states or southern states. So depending upon their forest area and what type of the tribal people they are collecting and how they are processing that, even like in Chhattisgarh or this tobacco leaves, this comes as a, you can say, the forest crop.
Thank you, sir.
Thank you.
For participants, if you have any question, you can write in the chat box, and you can unmute yourself also.
Okay, if
I
there's
think so. Yes, yes,
no
sir. There is
such
no question.
further,
Question, sir. Yes, sir.
thank you very much for joining me and listening me so patiently. I thank you, thank all of you for
Thank you, sir,
becoming
for
part of
coming.
this.
Yes, sir. Thank you. Your presentations were understandable. I think
So I should I leave now or want to continue?
no, no, sir. You can leave, sir.
Okay, thank you, ma'am. Thank you very much.
Thank you so much, sir. Thank you so much. Participants, we have a 20 minutes break.